Okay, now that we've seen the basic idea behind sockets in the terminal, we're ready to talk about how to programmatically open them in C using a series of system calls. So before I dive into that, let me just quickly review file streams, because that'll be a good precursor into what we're going to do with sockets. So if I were to make this file stream, I'll call it fout. I'll say fopen, let's just say out.txt, and I'll write to it. And W, if you recall, means overwrite. Okay, and then I could say something like fprintf fout hello world, right, or hello file. And then I would say close fout. All right, so just to run this, test this real quick. Oh, I meant to say fclose. Okay. So whenever you see that implicit declaration, that means that that's not actually a function that's defined in anything that's linked to there. But anyway, so I run this, and now I see a new file. It's called out.txt. It says hello file. Great. But I also want to remind you that one thing that's happening here is this is a file stream. That file stream is associated to a file descriptor, which again is a number that is associated to this file that you can interact with. So if I print that out, I can call the method file now, or file number, file. And there's a number here associated to that. Whoop. Let me run this. Oh, whoops. Okay, so let's see. I printed this after I closed it, so it said -1. Okay, so that's good to know. -1 means it's invalid. Okay, so these are always going to be, they should be greater than 2, because 1 and 2 are standard out and standard error respectively. So yeah, let's try that again. Before I close the file, it tells me the file descriptor is 3. And again, that makes sense because 1, 2, 3 would be the next available file descriptor. Okay, but so the reason I'm telling you all this is because setting up sockets is kind of similar. We just do it a little bit backwards. So first we get a file descriptor number by calling this method called socket. And so let me actually just look at the man pages for this first. Okay, so apparently you have to include something called sys/socket.h, so let me throw that in there. And then it says, okay, it creates an endpoint for communication and returns a file descriptor, just as I was saying. Now, as far as parameters go, the socket system call takes 3. So the first one is domain, which, as the documentation says here, is a communication domain. And this can be everything from Bluetooth, actually, to regular internet communication on your device here. I'm going to use this one. So this is IPv4. This is 4-byte IP addresses like 127.0.0.1. But also people are starting to use IPv6 more often. But I'll start with this one. Okay, so let me start my system call here. I'll say int sockfd to remind myself again this is returning a file descriptor. I'll say socket. Okay, first parameter AF inet. But you could just as easily, program Bluetooth if you wanted to. Okay, once this is selected, there are some types of protocols available. And so the ones that I'm going to focus on here are sockstream and sockdgram. Sockstream is the TCP connection. That was the first one I showed when I was in the terminal. And dgram is for UDP. Okay, but I'm going to start with TCP for sockstream, so the reliable two-way communication. And you can narrow it down further with this third command, but actually for TCP there's only one option, so it turns out you just pass a 0 to the third. And you see this is all explained in the documentation here. All right, so I'm just going to say here sock dgram and 0. All right, so those are my 3 parameters to the socket method. Now I should look carefully at what's returned here. And so let me just print this out to the terminal. And okay, so let me go ahead and compile this. So and I do that and I run it and I see, oh, actually, guess what? Just like the first available file descriptor for writing out to a file was 3, it made my socket 3 now because that's the first file descriptor that I'm creating in this program. Okay, that's cool. So that's encouraging. But let me see, if I pass some bogus parameter here, it will return -1. Okay, so that means it wasn't able to create that socket. So you should definitely check to make sure that this worked. All right, so what I'll do is make sure that I check to see if this is -1. And if it is, then I will print something to standard error about what went wrong. So I'll say error number blank opening socket. So it turns out there is also a special number in runtime called error no, which is the error number. So there's some kind of error code associated to the problem that happened here. And then what I'll do is I'll just exit the program with that error code. And so let me compile this. Oh, actually, okay, so I need to include errorno.h to be able to use this. And I also need to include stdlib.h for the exit. Okay, so I'll do that, include stdlib.h, include error number.h. All right, let's try this again. So let me clear that. All right, so now I run this, and it says error number 22 opening socket. Now what on earth is 22? So I can look this up. If there's a command called error no in bash, or I think I might have had to install something special, but okay, so it says invalid argument, which makes sense, right? I just gave a bogus argument here. Okay, so let me turn that back to 0. But yeah, so this is cool. So you know, look at what these errors are, and then you can look them up in the terminal. All right, but anyway, so now I'm not doing that anymore. So I run this, and nothing special happens. It just tells me I have a file descriptor number 3 that's ready to open a stream. Okay, so this is going to be kind of backwards of how I did it here. Here I set up the stream first, and then it told you what the file descriptor was. Here I'm actually, my first step is set up file descriptor for socket, and then the next thing I need to do is set up the stream on the socket. All right. So first step is set up the file descriptor, and now I'm going to set up the stream. This is a little bit more complicated than it was for a file, because we actually have to give a lot of information about the network, what the network needs to do to connect to this. And so first, I actually just need to set up a structure holding information about the IP address and the port that I'm going to use to set up a stream on this socket. And so to do that, there's a special struct that I'm going to use for IPv4 called sockaddrin. Okay. So let me actually just look at the man pages for that real quick. Struct. Whoops. Sockaddr. Actually, I should say IN. This is internet, right? Like, it's the one that corresponds to AFINet here. Okay, so this brought up the man pages for a whole bunch of stuff. Actually, all the possibilities they can do. So here I see, okay, this contains a port, and it also contains the, this AFINet. So I might as well just write that in there. So I'll say, yeah. So let me define a variable. I'll call this maybe net info. So I'll say net info dot, or maybe I'll call it addr info. So I'll say addr info dot, let me check that again. It was, okay, sin family equals AFINet. So that's not too bad. Now the port it's looking for, this is of type import _ t, which should be, let me just look at this. If I printf size of this type here, import t, I think this should be a 2-byte number. So the largest port that you can have is 65535. That's because it's 2 bytes. So let me just check this real quick. Well, this little bug was so difficult that it took me all day to resolve, and now I'm in a totally new city. No, actually it wasn't that bad. I just should have looked at the man pages, because when I do that, I see that I'm supposed to include net/in.h.
So I did that. As soon as I include that, the thing will compile. Let me do that. Compiles just fine. And when I run it, as promised, the size of the port is 2 bytes. All right. So let's go ahead and put in the port. So I'll say address info.sn port equals, I'll use the same port as before. But actually, something is wrong here. And I'll tell you what it is in a second. See if you can think what might be wrong based on other videos I've posted recently. But I'll keep going for now. The last piece of information I need to fill in here is the IP address. And this, I'll just tell you straight up, this is a 4-byte piece of information, if you look at it. In fact, okay, so we have, if I look at this in address, actually it wraps around another thing, which is 4 bytes. Okay, so I have to go 2 layers deep into it. So I'll say addr info dot sn address dot s address. Okay. Now, I'm not going to set this directly. What I'm going to do instead is actually use this method to convert a string IP address. So in this case, I'll use 127.0.0.1. There is a method to convert the string IP address into this 4-byte address. And that method is called inetpton. Inet underscore pton. So this is going to convert the internet address from a pointer to a character string into this destination, which is actually going to be a numerical representation of the address. So I'm supposed to pass it a pointer to the string, which I'm already doing. I just put that string literal 127.0.0.1. The destination is actually going to be this. So let me say that here. So inet pton, and actually the first parameter is the same thing as before, af underscore inet, so that it knows that I'm trying to convert this string into a 4-byte IPv4 address. So say af inet. Put my string literal there, second parameter. And then my third parameter will be a pointer to the location where this is supposed to reside. All right. Let me make sure I can compile this, and then I'll, not make, but there we go. Okay, well, once again, I forgot to include something, so let me go look back at this. I should be including arpa/inet.h. So always look very carefully at these man pages here. There we go. Now, let me actually, so this should be 4 bytes. Let me print out what ended up in this piece of information. So yeah, we're filling in the struct, and we're doing it very carefully because this is the information that we need to actually set up the stream here. So let's see, did we end up with this IP address? It should be, 127 is a 0 followed by 7-1, so that should be hex 7F. So let me print out this IP address in hex, whatever it converted this to. So maybe I'll say IP here, and then put a line break after it. Let's see what that comes out in hex. So when I run this, okay, so I see the 7F, and I see the 1, right, on the other end. But they came out in the other order, didn't they? So what do we remember? Well, so I'm running an Intel processor here, which means that it's storing this 4-byte integer in little endian order. So the least significant byte comes first, that's the 1. And then the most significant byte comes last, that's the 7F, or the 127. But actually, in memory, it's putting the most significant byte first because that's what the network is expecting. So really, if I were to look at this, the 7F would be first in memory. It's just that when I print it this way on my processor, it interprets the first byte as the least significant byte. So anyway, this is actually correct because this is how we want to send it over the network, but my computer thinks it's backwards. If you happen to be on a big endian computer, you won't have this problem. But that's part of the reason that we need to use, other than actually converting the string into a byte representation, part of the reason that we need to use this special method baked into that, on my platform that will compile into something that understands the conversion from little endian to big endian if it's needed. And so we have to do the same thing to the port, because this number, this 2-byte number in my processor is going to be stored in little endian order, but I need to transmit it in big endian order. So if you remember, there are these methods. The one I'm looking for here should be called H2NS. So this is host to network short. So that would be the 2-byte thing. And I just wanted to check what I need to include here. Okay, I've already got it, arpa/inet.h. So, okay, yeah, H2 network short. So I have to say that around this. All right, that was super annoying, but we have the header set up now, and we can open a connection to a stream on the socket. And the method to do that is, well, you guessed it, is called connect. So let me look at the man pages here. And connect is supposed to take the file descriptor of the socket we're going to open the connection on, a pointer to that information that we just made, and then the length of the struct containing all that information. Because we'll actually have a longer struct if we've done IPv6, because that actually is 128 bits instead of 32. So it needs to know how big the structure is containing this information. And actually, I'm also going to need to cast the pointer to this information to this type. All right. So finally, I'm going to call this method connect. So let me look at the result here. This is going to return an error code, possibly, if I'm not able to do this. But yeah, so first is a file descriptor, sockfd. Next is a casted pointer to this information that I just filled out. So this is addr info. And then finally, it's the size of that. Okay, and that should be all we need to connect. Now, again, good practice. Let me look and see if there's an error code that's coming back from this. And actually, the other thing I noticed, I had accidentally set this up as sock dgram. That was a UDP socket. I'm going to use a TCP socket instead. So I changed this to sock stream. I just misspoke on that earlier. So let me use the TCP socket with sock stream. So, okay, so now we've got this all set up. It's connecting. Or if there's a problem, it's going to tell us the error code, and we can have a look at what that is. Okay, so let's just run this. Everything seems okay so far. Somehow we were able to make a connection. Okay, so now that we've got this connection set up, we can try to open it up. Open up a stream. And actually, the way of doing this in general would be something called fd open, file descriptor open. So I would say file descriptor open, sockfd, and I'll say write. Let's say I'm going to write to the socket. Again, let me just see if there's any problems with this. I'll say if ret. Oh, I should have said ret up here. Okay, if ret is equal to -1, we'll say error number 5, opening file descriptor stream. Okay, let's try that out. Oh, I should have said, okay, yeah, this is supposed to be a file. Yeah, so I'll call this f out. Okay, let's try this. And it's a pointer. Okay, I should say null. If it's a null pointer, then something went wrong. Okay, now we're set. All right. So actually, I get an error code, which I was expecting to get before. Now that this makes more sense. It can't actually even open the socket right now. It gives me error code number 111. So what is that? Error number. It says connection refused. Well, the reason is I'm not actually running a server on this port right now. So I should be getting that. Let me pop up a server in another terminal. So let me bring this up over here. And it's going to be a TCP connection. So I can use netcat, which does TCP incoming connections by default. So I'll say netcat. Let's listen on port 60,000. Get that running there. And now I shouldn't get that error number. Okay, so this time you notice actually the server accepted the connection, but I didn't send anything. But I didn't get that error. Okay, so now that I have this file descriptor, I can actually print it. I can say fprintf, fout, hello, remote person. So why don't I send over line break too? Oh, and just to show you, we could do a format string as well. So I could say hello, remote person, blah, and maybe I'll say 475 since that's this class. And let me compile this. Whoops, let me compile. Go run this again. And you notice we successfully sent a message. Yay, okay. So after all these steps, we were able to get a message over a TCP connection. Okay, but I'd be remiss if I didn't tell you that this is not really the correct way to send stuff over a socket stream. Really, we want to instead use a method called send, which is set up for sockets. It gives us a little more control and a little more information about how the connection is actually going. So if we look at the man page for send, I see this is a method that takes 3 parameters: the socket file descriptor, a pointer to a buffer of information to send, and how many bytes in the buffer we want to send. And one more parameter if you want to have a little more control and set some extra flags to control this, like these kind of things. But just to tell you, this is nice because it returns how many bytes it actually sent, which may not be as many bytes as you wanted to send because of things buffering or any other number of reasons. So that's a good thing to know. So we kind of want to use this instead. What I'll do is I'll call this, and I'm supposed to provide the socket file descriptor. And actually now I need a pointer to a buffer that's already been allocated with all the stuff I want to send. So I'll say, okay, my message is hello remote person 475. And this time, I could use a format string, so I'm saving this to a string here. I could use sprintf if I wanted to format this, but I'm just going to keep it like this for now. But now I have to be a little more explicit about, the third argument here is how many bytes I actually intend to send. So I need to say, call some method like strlen in the string class. So I've included string.h up here so I can call this method to get the length of the string. This method is going to go through until it finds the null terminator, and it'll return as many characters as there were before that point. I actually also want to send the null terminator, so I'll say +1 here. And then I'm not going to use any flags, so I'll make the last parameter 0. Nothing special I'm going to do here. So let me go ahead and print out how many bytes were sent. And actually, just to let myself know, I'll also say, how many I tried to send. So I'll say, actually, try. It makes more sense to say try to send this many bytes. So first thing here, len, or bytes sent. And the second thing is len. That's how many bytes I'm trying to send. And then also I want to close the socket when I'm done. So I'll say close sock fd. And actually, close, it's different from fclose. Let me look up. So if I look up close here, I need to include uni.std.h. So all these little things, you got to make sure you include the right libraries. That seems to be the theme of this video. So it turns out for a socket, I need to use the close method and not fclose. Okay, so basically special method for sending things over the socket stream, special method for closing the socket stream. But otherwise, it is very similar to regular file descriptors. So let's run this. And let me see what it does. Oh, I should also, of course, be sure to, if I run it now, it's going to say error number 111, which we know is connection refused. Let me fire up netcat here. We'll try it again. And everything worked. I sent 26 bytes. And that was how many I tried to send. And if you check, that should be the number of bytes in this character string here, including the null terminator. Excellent. Okay, so we were able to finally make this. And, once you understand the steps, it's really not that much code. It's just a little bit more intricate than an ordinary file descriptor because we have to establish this connection on the right IP address and the right port. So we're basically done. This is a fully functional TCP client. You could change it to a UDP client by changing the to stock dgram. And in the next video, I'll show you how to do something with DNS if you say didn't know the IP address you're trying to send to. Instead, you had like a URL like google.com or something, and you needed to resolve an IP address. But this is enough to get you started. So there you have it.